Video problem number 60, the ideal gas law. So the big thing that students often have trouble with is determining when to use the combined gas law, when to use the ideal gas law. Use the combined gas law when you're changing something about the gas. Use the ideal gas law when you're just completely describing it. So in other words, you're not changing the volume, you're not changing the pressure, you're not changing the temperature, you're not changing the number of moles, you're not changing anything about the gas, you're just describing the gas. So here's an example. A 5.2 times 10 to the negative third mole sample, so my moles is equal to 5.2 times 10 to the negative third of gas at 13 degrees Celsius, so my temperature is 13 degrees Celsius. It's a gas, so let's just go ahead and change that to Kelvin. Occupies 235 milliliters of space, so the, here, let's make it volume. Volume is equal to 235 milliliters. Determine the pressure of the gas. So notice that I'm not doing anything to the gas, I'm just describing it. So that means I'm going to use the ideal gas law, which is PV equals nRT. Right? So I have N, I have T, I have V, I'm looking for P, but what about R? Well, R is a constant. So R is 0.0821, and that's liters times atmospheres divided by moles times Kelvin. So in other words, I have to have my units in liter, atmosphere, mole, and Kelvin. Right. So the only thing I don't have here, this is mole, Kelvin, I don't have liters. So let's change that to liters. So that's 0.235 liters. If you really want to see that worked out, I can work that out for you. 235 milliliters. Let's see, I got milliliters on bottom, liters on top. There are 1,000 milliliters in 1 liter, so divided by 1,000. Right. So now it's just plug and chug. I'm solving for P, so it's going to be P is equal to nRT over V. The N is 5.2 times 10 to the negative third moles. Right. The R is 0.0821, that's liter atmosphere per mole Kelvin. The T is 286 Kelvin. And then divide the whole thing by that volume, which is, we figured out was 0.235 liters. So look, see, moles cancel out, kelvins cancel out, liters cancel out, I end up with atmospheres, and that's good, because that's what I'm looking for. So 5.2 e to the negative third times 0.0821 times 286, and the whole thing divided by 0.235. So I get a value of, how many sig figs? 2 sig figs because of the temperature. So the pressure is equal to 0.52, and that's going to be what, atmospheres.